Okay, so this page is all about slope. And slope is one of those things that we can represent in a number of different ways. So we're just going to highlight those ways. And again, this should be a bit of a review for you, but it's really important stuff. So it's good to have all these notes written and as a reference for you. So let's talk about slope. Now, slope can be shown in a few different ways, but the general idea with a slope is it's the steepness of a line. The steepness of a line. Okay, so slope is kind of steepness. Now we can have four different types of slopes. The most common ones would be positive and negative. So if it is positive, that means from left to right, you are increasing. If it is negative, from left to right, you are decreasing. You're going down. If it is a zero slope, that means that it is horizontal, so straight across. Let's see if I can make that horizontal line. Let me try that one more time. There we go. So straight across means zero slope, so slope of zero. And if it's a vertical line, that's called undefined slope. And the reason being is that you would have zero in the run, and you can't divide by zero. If you try to do that, you'll get an undefined answer on your calculator. So if it's straight up and down like a wall, that is an undefined slope. If it's straight side to side like a floor, that is zero slope. All right, sometimes we think of the slope numerically. Having trouble talking here. Sometimes we think of the slope numerically, and rise over run is a way to remember how to write the slope. And so when we talk about rise over run, we're really talking about how much the vertical amount of change is compared to how much the horizontal changes, or how much the y changes divided by how much the x changes. So a slope formula helps us remember that. So if I have just two generic points, let's call one point x1, y1, x1 comma y1, and x2, y2. I mean, these are ordered pairs. I can put a little comma in between there. Then our slope formula tells us that to get the slope, we just subtract the two y values. I usually take the second y value minus the first one. And that's like your rise. And then subtract the two x values. And I usually take the second x value minus the first one. So x2 minus x1 just means the second x value minus the first one to get your run. So that is our slope formula. So if we want to then calculate the slope, like down here, let's just label this x1, y1, x2, y2. Remember, every one of these points is called an ordered pair, and every ordered pair point has an x value and a y value. So if we are going to go ahead and calculate the slope, we'll subtract the y values to get the rise. So take the second one minus the first one. So 7 minus 8 would be second y value minus the first y value. So again, I'm using this little formula up here. And then the second x value minus the first x value would be 4 minus 2. So if I subtract, that would be 7 minus 8 is negative 1. 4 minus 2 is 2. So negative 1/2 or negative 0.5, if you prefer decimal, would be the slope. Let's do that same thing for the second set. So x1, y1, x2, y2 for the two ordered pairs. And I will subtract the second y value minus the first y value to get the rise. So 9 minus 3 divided by the second x value minus the first x value, negative 2 minus 1. So that gives me 9 minus 3 is 6. And we have negative 2 minus 1 is negative 3. So that gives me a negative 2 for my slope. Negative 2 over 1 if you want to reduce it, which of course then just goes to negative 2. All right. I'm messing around too much here. All right. So in that process, we talked about change in y over change in x, which is really what we're talking about down here. Sometimes that is referred to, especially in science, as delta y over delta x. That little triangle is actually the Greek letter delta, and that is a little symbol in math and science that represents change. So it's a shorthand way of saying change in y over change in x. You may hear your science teacher say delta y over delta x to represent that change. And then we can write the equation in a couple different forms, actually 3 forms. We're going to focus on 2 though. And the one is we talked about on the first page, which was the slope-intercept form. So slope-intercept form is y equals mx plus b. So you've got the y value that's changing, but you have a slope that always stays the same. You've got an x value that's changing, and then you have a y-intercept that's always staying the same on a line. All right, so we're going to fill in numbers for the m and for the b here, and the number that we'll put in for the m is the slope, and the number that we end up putting in for the b is the y-intercept, where the graph crosses the y-axis. So there'll be numbers in those 2 spots for our equation of our line. The x and the y value are changing, so we just keep those as x and y, because there's many points that are on a line that each have an x and a y value. But a line will always have the same slope and same y-intercept for a particular line. And then we have the point slope form. This one isn't talked about as much maybe at the beginning, but it definitely is one of my favorite forms. So it looks like this. We have y minus y1, code here, equals m times parentheses x minus x1. Okay? And so instead of doing slope and y-intercept, we still have a slope here. Notice slope is still represented by the letter m. But the numbers that we have instead of a y-intercept are actually going to fill in these 2 slots here and here, which would be a point that's on the line. So point on line. Any point that's on a line, any ordered pair, could be filled into these 2 spots, and we would have the equation for the line in point slope form. So if you knew for sure that there was a point on the line that was like 2, 3, well, you could put the 2 in for the x1 and 3 in for the y1, and then whatever the slope is you put in for m, and then you have the equation. We will practice that on the next page.